code installs the package yfinance and backtrader using the pip installer. This installs all the necessary dependencies and files needed for the yfinance and backtrader packages to function properly on the current system. This could be used to retrieve financial data and perform backtesting on a trading strategy. Installation using the pip installer ensures that all the necessary files and dependencies are downloaded and configured correctly, making the packages usable for the user. Code imports the necessary libraries and modules, such as NLTK, yfinance, and pandas, to perform sentiment analysis and create a word cloud. It also imports backtrader to help visualize financial data. The first line imports NLTK, which is a natural language processing library. The next line imports the sentiment intensity analyzer from NLTK's Vader library, which is used to analyze sentiment in text. The following two lines import the requests and yfinance modules, which are used to retrieve financial data from the web. The line after that imports the word cloud and stop words from the word cloud library, which is used to create a visual representation of the most common words in a text. The next line imports bday from the pandas.tseries.offsets module, which is used to handle business day data. The next two lines import pandas and matplotlib.pyplot as PLT, which are used for data analysis and visualization. Finally, backtrader is imported as BT and backtrader.indicators is imported as btiend, which are used for analyzing and visualizing financial data. The last line downloads the Vader lexicon from NLTK, which is a lexicon containing ratings for words commonly used in sentiment analysis. Code creates an analyzer object. Specifically, it creates an object of the sentiment intensity analyzer class. This object can be used to analyze the sentiment of text or strings. The code does not perform any sentiment analysis itself. It simply creates an object that can be used for this task. This object will have access to various methods and tools for sentiment analysis, allowing for the evaluation of the emotional content of text. This code takes a list of sentences and performs sentiment analysis on each one. The list contains different variations of the sentence, "Bob is smart, boring, and creative," including different punctuations, capitalizations, and degree modifiers, as well as one sentence with a conjunction and one with a negation. Using a for loop, the code iterates through each sentence in the list. Within the loop, the sentiment analysis is performed using the analyzer.polarity scores function. This function takes each sentence as input and returns a dictionary with keys corresponding to different aspects of sentiment analysis, such as positive, negative, neutral, and compound scores. The code then prints each sentence along with its sentiment analysis results in the format sentence analysis results. The analysis results are converted to a string using the star function. The analysis results for each sentence include the compound score, which indicates the overall sentiment of as well as scores for positive, negative, and neutral sentiment. Overall, this code performs sentiment analysis on a list of sentences, which can help to determine the overall sentiment and individual sentiments within each sentence. This can be useful for tasks such as opinion mining, brand monitoring, and customer feedback analysis. Above code retrieves the stock data for Apple Inc. AAPL for the year 2021. First, the code imports the necessary libraries, including yfinance, which allows us to retrieve data from Yahoo Finance. Next, it creates a ticker object for Apple Inc. with the ticker symbol AAPL. This object is assigned to the variable AAPL. Then, the code uses the history function to retrieve stock data for Apple Inc. from January 1st, 2022 to February 26th, 2022 with a daily interval. This data is then stored in a data frame called df_apple. Finally, the code prints the first few rows of the data frame to get a quick glimpse of the data. This code is using the newsapi.org API to get information about articles related to Apple and sort them by popularity. It specifies the query keyword, Apple, the sorting method, popularity, the desired number of articles, 100, and the API key in the parameters variable. Then it sends a GET request to the News API using the specified endpoint URL and parameters. The response variable stores the result of the request, which can then be used to access the information about the articles. Code creates a new data frame called df_news and assigns it the JSON data contained in the articles key of the response object. It then converts the published at column into datetime format and sorts the data frame by that column in ascending order. Finally, it displays the first 6 rows of the sorted data frame. Code imports a library called stopwords and initializes an empty string called words. Then, it loops through the description column in a data frame called df_news, splitting each description into separate words and converting them to lowercase. These words are then added to the word string with spaces in between. Next, a word cloud object is created with specified dimensions, background color, and minimum font size, using the list of stopwords from the stopwords library to filter out common words. Finally, the word cloud is displayed using the matplotlib library. Essentially, this code creates a visual representation of the most common words used in the descriptions about Apple in the data frame, excluding common words like the, and of. Code df_news.shape returns information about the dimensions of the data frame called df_news. Specifically, it returns a tuple with 2 elements, the number of rows and columns in the data frame. The first element represents the number of rows, while the second element represents the number of columns. The function shape is common in data analysis and is used to get a quick understanding of the size of the dataset being worked with. This can be useful when trying to understand the overall structure of the data or when performing operations that involve selecting subsets of rows or columns. In summary, this line of code is used to get the size of the data frame in terms of rows and columns. Code is a function that takes in a date as an input and returns the business day for which a particular news headline should be used to make trade calls. The first line is a comment describing the purpose of the function. The next few lines of code set variables for the opening and closing times of the current date, previous date, and next date. These times are calculated by getting the floor, or nearest rounded down date, of the input date and setting specific hours and minutes. The Nagish B day 0 subtracts the current date's business day, ensuring that the dates are accurate for trading days. The next few lines are comments that explain the purpose of the following code. The code inside the if statement checks if the input date falls between the previous date's closing time and the current date's opening time. If so, the function returns the current date's opening time. The elif statement checks if the input date falls between the current date's closing time and the next date's opening time. If so, the function returns the next date's opening time. If the input date does not fall into any of these time ranges, the function returns none. Overall, this function is useful for determining the specific trading day to use for a particular news headline, taking into account weekends and holidays. This can ensure that trade calls are made on appropriate and accurate business days. Code applies a function called getTradeOpen to the published at column of a data frame called dfNews. The function extracts the trade open time from the date and time provided in the published at column. The dt.date part converts the resulting datetime object into just a date. This is then assigned to a new column called date in the dfNews data frame. Next, the code filters out any rows where the date column is null, meaning the function could not extract a valid date. Finally, the head method is used to display the first few rows of the updated data frame. Essentially, this code helps to clean and format the date data in the published at column of the dfNews data frame by applying a function and then filtering out any null values. Code computes a compound Vader score for each news headline in the data frame using the title column. This score is calculated by applying a lambda function to the title column, which uses the analyzer.polarityScores function to extract the compound score from the Vader sentiment analyzer. The compound score is a metric that combines the positive, negative, and neutral scores of a text to give an overall sentiment score. The resulting compound scores are added to a new column in the data frame called compound Vader score. The .head function is then used to display the first few rows of the updated data frame. Essentially, this code allows for sentiment analysis of news headlines using the Vader model. Code retrieves the shape of the data frame df_scored news, which refers to the number of rows and columns in the data frame. The shape is returned in the form of a tuple with the first value representing the number of rows and the second value representing the number of columns. This can be useful for understanding the size and structure of the dataset as well as for performing various data analysis and manipulation tasks. No changes are made to the dataset itself. It simply provides information about its dimensions. This code takes a data frame, dfNews, and groups the data by date using the date column. Then it uses the .add function to aggregate the data and calculate the maximum and minimum values for the compound Vader score column. These values are assigned to new columns in the data frame named compound Vader score max and compound Vader score min. Finally, the .head function is used to display the first few rows of the resulting data frame, df scores. Overall, the code is used to calculate and display the highest and lowest Vader sentiment scores for each date in the dataset. This code creates a new column in the data frame called final scores and assigns the sum of two existing columns, compound Vader score max and compound Vader score min, as the values for this new column. The code then displays the first few rows of the updated data frame. Essentially, this code is combining the maximum and minimum sentiment scores for each entry to get a final sentiment score. Firstly, the code uses df scores, which refers to the data frame built using the data provided in the code. Next, .shape is used to retrieve the dimensions of the data frame, which is then printed or displayed as the output. The dimensions returned are in the form of rows and columns. This helps in getting a quick overview of the structure of the data frame. This code first creates a new data frame called dfFinal by joining two existing data frames, dfApple and dfScores. This means that the data from these two data frames is combined into one, with rows from the first data frame followed by rows from the second data frame. Next, a new column called Final Scores is added to this combined data frame. This column is filled with 0 values for all rows. Finally, the first 5 rows of this new data frame are displayed using the head function. This allows the user to check that the data has been combined correctly and the new column has been added. This code imports the necessary libraries for backtesting and calls the dataset dfFinal. Then, It assigns the parameters for the backtesting, such as the start cash, commission, and stake. The start cash indicates the amount of money available for trading, while the commission is the percentage amount charged for each trade. The stake represents the quantity of stocks or assets to buy/sell for each trade. These parameters are important to simulate real trading conditions and analyze the profitability of a trading strategy. This code starts by defining a class called TradeLogger, which inherits from the bt.analyzers.analyzer class. This class will be used to return information about closed trades. The class has three methods: start, create analysis, and notify trade. The start method calls the super function to initialize the attributes from the bt.analyzers.analyzer class. The create analysis method creates a list called rets and a dictionary called vals. These will be used to store the trade information. The notify trade method is called before each cycle and receives trade notifications. It checks if the trade is closed, and if so, it stores information about the trade in vals and appends it to rets. The get analysis method simply returns the rets list. The set and run function is used to initialize the BT Cerebro engine and add the strategy, data, and initial capital. It also sets the broker's commission and adds a sizer for buying and selling shares. The function then adds two analyzers, bt.analyzers.sharp-ratio and TradeLogger. The engine is then run and the results are printed. The Sharp ratio measures the risk-adjusted return of an investment. The TradeLogger returns a list of closed trades with information such as date, gross P&L, net P&L, trade commission, and duration. Finally, the function uses matplotlib to plot the results and a table using the pandas library. Code defines two classes, sentiment and sentiment strategy, which have functions and parameters that will be used to execute a trading strategy. The sentiment class is an indicator that calculates and tracks the sentiment of a stock using the final scores data from a data frame called dfFinal. The next function in this class retrieves the current date, converts it to a numerical value, and assigns the sentiment value for that date to the sentiment variable. This variable is then used to update the sentiment line in the class. The sentiment strategy class is a strategy that uses the sentiment class and sets parameters for positive and negative values. The init function initializes the sentiment class within the strategy. The notify order function is used to execute a trade based on the current sentiment. If there is no position, i.e. not currently holding the stock, the code prints a message and returns. If there is a position, the code checks the sentiment, and if it meets the specified positive or negative threshold, it will buy or sell accordingly. The next function in the sentiment strategy class is used to update the sentiment value for the current date and compares it to the positive and negative parameters set in the init function. If there is no current position and the sentiment is above the positive threshold, the code will execute a buy. Otherwise, if the sentiment is below the negative threshold, the code will execute a sell. In summary, this code uses the sentiment class to track the sentiment of a stock and uses the sentiment strategy class to execute trades based on the current sentiment and predefined positive and negative thresholds. It allows for automated trading based on sentiment analysis of a stock. first line of the code initializes a backtesting object called Cerebro. Next, it adds data to be backtested to this object. The strats variable is then created, which has the strategy for the backtesting. This strategy is defined as the sentiment strategy and has two parameters, positive and negative, which are arrays with specific values. The next few lines set up the broker for the backtesting, including setting the initial cash and commission for each trade. A sizer is then added, which determines the size of each trade. The last 4 lines of the code add analyzers to the backtesting. These analyzers are used to calculate the Sharpe ratio and variability-weighted return for each result. The backtesting is then run and the results are stored in results. The last line of the code creates a data frame with the results of the backtesting. The for loop iterates through each result in the results variable and adds the values of the positive and negative parameters, as well as the calculated Sharpe ratio and variability-weighted return to the data frame. The data frame is then displayed, sorted by the Sharpe ratio in descending order. Overall, this code sets up and runs a backtesting process with a specific strategy and analyzers and displays the results in a data frame. The purpose of this code is to test different positive and negative thresholds for Vader scores and determine the most profitable combination. Code first calls the function setAndRun and passes it several arguments, including the data, likely containing sentiment analysis data, the sentiment strategy, likely a predetermined algorithm or calculation, the starting amount of cash to use, the commission amount, and the stake, likely the specific investment amount to use. Next, the setAndRun function will run on the provided data and strategy using the specified starting cash, commission, and stake. This may involve analyzing the data and using the strategy to determine when to make investments and adjustments. Once the function has completed running, it will plot the results, likely showing the performance over time of the chosen strategy on the given data. This may be helpful in visually understanding how the strategy performed and if any changes or adjustments need to be made. In summary, this code is using a predetermined sentiment strategy to analyze data and make investment decisions, then plotting the results to visualize the performance of the strategy.